Hi, hello, and welcome to day one of differential equations. Um, well, I guess technically day two. We did have the syllabus yesterday, but today, welcome to the first day of learning differential equations. And today, we're just going to talk about definitions, terminology, how we can tell if we have a solution to a differential equation. And so, we're going to start off with the definition of a differential. And so, an equation containing the derivatives of one or more unknown functions or dependent variables with respect to one or more independent variables is said to be a differential equation. If you have a derivative in your equation, you're dealing with differential equations. We will classify differential equations according to type, order, and linearity. So we're going to first talk about the types of differential equations, where we're going to talk about an ordinary differential equation. So an ordinary differential equation contains only one ordinary derivatives of one or more unknown functions with respect to a single independent variable. So, Calc 1, Calc 2, you're really used to dealing with ordinary differential equations where, we take the derivative of y with respect to x. That's just so that's where we're just taking it with a single independent variable. But even if we said, okay, let's take the derivative of g with respect to x, that's still an ordinary differential equation because we're taking it still with a single independent variable x. Now, a partial differential equation involves partial derivatives of one or more unknown functions of two or more independent variables. So that would be the gradient vector, where we took the partial derivative of y with respect to, or I guess partial derivative of f with respect to x plus the partial derivative of f with respect to y. So we took it to two different independent variables. So that's a partial differential equation. So those are the two different types. One with one single independent variable, and then other with two or more independent variables. So example one, we're just going to tell if the following equations are ordinary differential equations or partial differential equations. So for the first one, dy over dx minus 7y equals 3 sine x. When we look at all of our derivatives, we only have one derivative. It's a first order derivative, and it's just to respect to x, and so this is just going to be an ordinary differential equation. For 2, we have a second order differential equation with respect to x plus 2 times a first order differential equation with respect to x. So again, both of these with respect to x, so it's an ordinary differential equation. The next one, we have a second partial derivative of u with respect to x, and then a second partial derivative of u with respect to y. So two different independent variables, so that's a partial derivative, or partial differential equation. All right, again, we have the derivative of x with respect to t plus the derivative of y with respect to t. Because these still hold true for just one independent variable, it's an ordinary differential equation. All right, some notation. I guess I kind of talked about this last semester, the difference between Leibniz notation, prime notation, Newtonian or Newton's dot notation, subscript notation, kind of covered that when we were doing partial derivatives. But Leibniz notation is what you're used to seeing the dy over dx. Prime notation is the notation I like to use. Just because it's like a lot of less writing, and you can see it's an easier, I don't say easier, it's just less to have to write. And when I look at it, I know, hey, it's a derivative. Notice that, after you get y triple prime, it goes to y, and then you have 4 in parentheses. Again, it's not power 4 because it's in parentheses. That's the fourth derivative, fifth derivative of y, and that's how we represent anything beyond 3. Newton's dot notation, first derivative you have 1 dot, second derivative you have 2 dots, third derivative you have 3 dots. Subscript notation, we covered that in Calc 3, where you take the derivative of x 2 times here. It's a second order derivative of u with respect to y both times. This one's a second order derivative of u, first with x, then with y. So those are all the different notations that you're going to see in this class. Mainly, you're going to keep it in Leibniz and prime notation, but you'll see some of Newton's dot notation and subscript notation as well. So classification by order. The order of a differential equation, either ordinary differential or partial differential equation, is the order of the highest derivative in the equation. So let's look at this first one. All we're going to do is tell, okay, what is the order of this differential equation? So here we have a second derivative with respect to y over x plus 2 times the first derivative to the 7th power minus 6x to the 5th equals 0. So we're looking at our derivatives and the highest derivative. Our highest derivative is here. It's a second order derivative. This is a first order derivative taken to the 7th power. So the order of this differential equation is going to be a second order differential equation. And I'll go ahead and say ordinary differential equation because it is an ordinary differential equation.